All right.
Sorry, 1:30. Yes, 1:30, not 11:30.
Okay, good. That's good. So I'm 6-7 minutes late. Nice to see you, Shafiq.
Yeah.
I'm 6 or 7 minutes late, am I?
Yeah.
Yeah. Okay. Then it's not terrible. The reason is I'm in LA in one of those little airport cubicles, but I'm in the handicap one because the others are all full. So I'm on my knees here. But so I'm going to I'm going to turn off my video and share my screen. Or at least, yeah, let me share the screen. And then I'll switch to the presentation. After minimizing it. Come on. All right. All right. Well, apologies for the late start. And I hope the sound is good and that you can hear me. So the intent of today's workshop is to discuss with you how you might use the NHERI Science Plan, the third edition of the Science Plan. I'm going to start with a little overview of what's in the Science Plan, but along the way, I'm going to be asking questions, and I want to get a feel for how many folk could use a particular portion or which portions of the Science Plan resonate with you and your research. So please don't see this as a one-way presentation. I do want you to give me feedback. I might just ask for hands to go up. Yeah, let me see. Yes, okay. I can see the number of participants. So yeah, please just answer, just respond, just unmute yourself and speak up. This is an informal workshop. It's not a formal webinar presentation. So my name's Ian Robertson. I'm the Arthur N.L. Chiu Distinguished Professor at the University of Hawaii. And I led the effort to draft this third edition of the NHERI Science Plan. I have a QR code there that you can use to get a copy of the Science Plan, but hopefully you've all already downloaded a copy based on the email. So I'm assuming many people are familiar with the NHERI network, but in case you aren't, I just wanted to go through the NHERI wheel, starting at the top. This is Purdue University are the coordinators, the Network Coordinating Office. Let me get a better pointer. There we go. And then the rest of these facilities around the ring are the experimental or the Sim Center, which is the first one, is a computer-based simulation center. University of Texas is the design-safe storage of all data, and all software generated at SimCenter is available through DesignSafe, and you're obviously all logged through DesignSafe for this meeting. Lehigh University is a strong hybrid simulation testing facility. University of Florida and Florida FIU are wind research facilities. The large shake table at San Diego for seismic, the Geotech centrifuge at UC Davis, the Thumpers, Geotech experimentation soil testing down in University of Texas, Austin, wave basins at Oregon State University, and the Rapid Center for collecting field data at University of Washington, and finally the Converge, more recently added Converge social science aspect at the University of Colorado Boulder. We have more information on all of these. The new one is the niche, which is in planning at the moment for a combined wind and wave and surge type research facility at a much larger scale than we have at the moment. All of these are detailed in more detail in Appendix C, so whichever one you're interested in, obviously there's a lot more detail in that appendix. I'm not going to go through them any more than that. Get back to here. So this is not the first version, obviously, it's the third. The first version was developed by the NCO as a requirement of the NHERI contract. Each of the individual facilities was also required to produce a science plan, and so the NCO leveraged those science plans to develop this first edition. After it wasn't intended to be a permanent document. Obviously, it's a living document. Science plans need to change as demand changes, and as you complete some of the tasks, you move forward to others. So the NCO collected a lot of input on that first edition, decided to hold an international workshop, which was held in March of 2019, to get more input on the science plan and what could be improved. That workshop produced 5 comprehensive research campaigns, which are appendices to this second edition, and they're still good. We did not change them or update them. We simply added to them, but we didn't reprint them. So there are 5 research campaigns, and I'll tell you a little bit about them in the original second edition. That was published in January 2020. There was still a few things missing, or at least not covered in as much detail as we would have liked. And so we proposed to NSF that we update to a third edition, so as to do the following, basically to include social sciences, equity issues, climate change, and field reconnaissance, none of which the social science had been mentioned in the second edition, but really not covered in enough detail and not integrated into the engineering aspects of the research that's done at NHERI facilities. The laboratory research was already ongoing. The simulation tools, people were using their own tools, but SimCenter started a little later than the other experimental facilities, and it takes a while for them to ramp up the full simulation tools that they have available now. And so we wanted to feature those a little more. And then I have always liked the idea of having a practicing engineer, scientist in the research team to help to guide your work to something that can be used in the end of the day. So we added some practitioner guidance. So that was the reason for this third edition. And you can see the Converge, the field reconnaissance in the center, and a report from SimCenter of the tools that they have had available. And this is, I forget the date of that report, 2021. All right, so bringing the social science aspects into an essentially an engineering research facility is crucial. When we look at these disasters, this was the Maui fires just recently, Lahaina, 101 deaths, and many in their vehicles trying to escape. Fort Myers, people who decided to remain in their homes, even though storm surge was predicted, and we lost 150 folk and enormous damage. So as engineers, we can solve this damage. We can rebuild better. We know how to build for these conditions. We do know how to build for fire. We just haven't applied it. But we certainly know how to build for storm surge and wind. We just need to make sure we do it and that communities do it. But to get all of that done is really a social aspect, the policies that have to be set up, the working with politicians, trying to sway the public to motivate them to want this type of design and not to be satisfied with these disasters happening all the time. The fact that people were struggling to evacuate in this case, and here chose not to evacuate in many cases, that's a social science issue, that's a psychology, that's a sociology problem. As engineers, we're not going to solve those problems. So it was crucial that we got social science aspects included. So in the next 2 slides, I'm showing you the members of a task group that we put together specifically to write this third edition. And the ones in red are all social scientists. Prior to that, the only social scientist was Laurie Peak in both of the prior, the first and second editions. But now we have 7 social scientists on this team of 16. So they had a lot more influence, obviously, but we wanted their input so that, engineers writing stuff for social science is not going to happen. So it was extremely useful to have them on board. These are all very esteemed researchers in their fields. You may recognize some, but we were very lucky to have them all contribute to the drafting of this, the third edition of the science plan. That workshop was in 2022. We finally got it published in October 23. Again, there's the QR code and the link, but I'm hoping you have a copy already. And we're obviously trying to distribute it and disseminate the information as widely as possible, part of the reason for this workshop. We don't want this science plan to sit on the shelf or sit on the hard drive at Design Safe. We want it to be used, and that's the reason for this workshop. So, who's the audience for the science plan? Obviously, researchers working on geophysical and atmospheric hazards, but also researchers working in social sciences who would like to collaborate on these efforts in the geophysical atmospheric hazards. You might have noticed we're no longer talking about earthquake, wind, and storm surge and tsunami. We don't label them. We're talking about any geophysical concern. It could be predominantly seismic, but landslides, other geotechnical failures. And for atmospheric hazard, that covers everything that happens because of the atmosphere. So hurricanes, tornadoes, storm surge, the tsunamis come from earthquake, geophysical. So we're not limiting you to those traditional research areas for NHERI. Interior flooding would be included. Fire is in flooding. That's an atmospheric hazard. Drought conditions with lightning or people not being careful will start wildfires. So all of those aspects are now available, and NSF is funding wildfire research and inland flooding research. So they were not previously, but we want to make sure that those were included in the science plan. A major target, obviously this science plan is going to be read by the funding agencies so that they can see what the community is looking for. But obviously you folk, you junior researchers, and I have seen your registrations coming in as you've been signing up for this workshop. And a lot of junior faculty, PhD, postdoc, and early assistant professors, which is very encouraging. You are the target that we're looking for. And we've done the same thing at the Summer Institute. If you haven't had a chance to apply to the NHERI Summer Institute, it's too late for this year. But next year, there will be another Summer Institute. So when you see those emails coming out of Design Safe, consider applying. It's open to early career faculty and a few of the Graduate Student Council members. So the heart, if you like, of the science plan is the 3 grand challenges. If we can solve these challenges, then we have put ourselves out of business, as they say. But I suspect it's going to take a while for that to happen. And the first one is to identify and quantify the characteristics of not just single hazards, but co-occurring and compounding natural hazards, whether of geophysical and or atmospheric origin. So we have in the past often focused, I'm a hurricane engineer, or I'm a seismic engineer, or I'm a tsunami engineer. We've tended to focus and silo ourselves on one hazard. But many hazards are duplicative, or a one will cause another. For example, the earthquake causing a tsunami. So we do need to deal with them as co-occurring or compounding. Trying to think quickly. Yes, it was US Virgin Islands and Puerto Rico in 2017 got hit by 2 hurricanes 2 weeks apart, both Category 5, Irma and Maria. Category 5 hurricanes, 2 weeks apart. You've hardly finished the recovery, not recovery, but the search and rescue for the first event, and there's another one on top of it. Haiti was trying to recover from earthquake when, Puerto Rico was still recovering from those earthquakes when they had, from those hurricanes when they had an earthquake. So yeah, there's those would be compounding, one hazard and then within a short duration another hazard, not necessarily related to the first. The COVID pandemic was part of that as well. If you have a hazard during the pandemic, where do you evacuate people? How do you deal with it? That's not the only pandemic we're going to have, by the way. There will be more. And so we should be prepared for that eventuality. So these geophysical and atmospheric hazards have the potential to harm people, damage the civil infrastructure, and to disrupt communities. And a lot of our focus as engineers, at least, has been on the damage to civil infrastructure, buildings, roadways, bridges, etc. We haven't focused enough on the disruption to the community, the people who move out, who migrate, who don't come back, or just suffer in place for maybe decades before they can afford to rebuild and get their lives back up and operating. That's the first challenge, quantifying the hazard and how it has potential to injure or harm. The second is to assess the exposure, vulnerability, and adaptive capacity of civil infrastructure and social systems in areas threatened by these natural hazards. So how do we understand, and this is in a way something the social scientists can do almost independent of engineers, understanding how people respond, how they can better prepare, what their vulnerability is, how we can educate them on the threats, on the hazards that they face, is all the social science aspect. But for the engineers, we can work on maintaining the infrastructure, improving the infrastructure so that the communities aren't as disrupted by the event. And then finally, to solve these problems, we need to invest in a diverse hazards workforce. So education is crucial. Developing a workforce that can plan, can design for, and can mitigate these hazards. And develop technologies and tools to support the design, construction, retrofit, and operation of equitable, sustainable, and resilient civil infrastructure for the nation. The in-between term, the design, construct, and retrofit, those are things we know how to do. But getting the retrofit done is the problem. We can write codes now. The current code will survive, buildings will survive relatively well in all of the hazards we face if you build them to current code. Not 100%, but it's a pretty high performance rate. Unfortunately, the majority of the buildings out there are not built to current code. We've got an entire inventory of buildings that is built to no code whatsoever, or to an older code which is not as resilient as the ones we have now. Getting those retrofit is a very difficult task. Trying to persuade property owners that it's in their benefit economically and from a life safety point of view that they should be retrofitting is not an easy sell. I just read an article yesterday that San Francisco is now cataloging all suspect concrete buildings, you know, the old non-ductile concrete buildings, and then going to try to figure out how they mitigate, how they get the owners to retrofit. It's not going to be easy. And we need to do this equitably. People with money can normally get out of the hazard area, they can recover, they can start up their lives again, but the people without money struggle and suffer. And so it has to be equitable how we deal with finding solutions. It has to be sustainable. The more we can do to make these buildings survive multiple events, the better. And obviously trying to be resilient. So to expand on those three grand challenges, we developed 6 research questions. And I think this is where you can borrow some of the verbiage or actually take a quote from these sections and put it into your proposal to NSF or anyone else, any other funding agency. You can reference this science plan and provide quotes. How can the scientific community more effectively collect and share data and information? So this immediately makes me think of the EARS, the Extreme Event Reconnaissance and Research Networks. I'm a member of the STEER, Structural Extreme Event Reconnaissance. I would suggest that every one of you look at this wheel of the different EARS, and I've got them listed here: GEAR, Geotech, Social Science, Structural, Nearshore, Operations and Systems Engineering, Sustainable Material Management, Public Health, added just last year or fairly recently. And ICEER is the interdisciplinary hub that holds all of these together or tries to coordinate all of these disparate agency or research and reconnaissance networks. I strongly recommend that you join one in your field if you haven't already. We typically work on Slack. I know Steer and Seer and NER all work on Slack. I can't speak to the others because I'm not members, but yeah, if events occur, Gear and Steer certainly will get the word out. NER actually starts working on it ahead of time, putting sensors out to track the storm surge and wave action, etc. Yeah, please join one of these to get ideas, to get involved, to start working on reports, to do virtual reconnaissance on events, and possibly eventually get out in a rapid or a field survey. And rapid grants are one of the easiest ways for a young faculty member to get NSF funding. We all want NSF funding, but it's not easy. If you've tried already, you might have found that the return rate or the success rate is relatively low, on the order of 20, maybe less % of proposals get funded. But rapids are obviously limited budget, relatively small, but they go through a very quick review, typically just by the director. And the experience for you, I promise, will be life-changing. It will be invaluable. My first rapid was for Hurricane Katrina, 2005. We'd made 2 trips down to collect data. It's just phenomenal how much you can learn after a tragedy like that. It's a horrible event, but it is an event that we can benefit from. So please take advantage of that opportunity. So continuing on the collecting and sharing data reuse is another drive that NSF has. We've collected an enormous, just phenomenal. I don't know where DesignSafe puts it all myself. I guess seriously, the amount of data that Steer has sent in, Gear and the others, I'm sure, plus all of the people doing their research at the facilities. It's, yeah, the storage space they have is phenomenal, and it's all doubly backed up so that it's safe. That data are there, those data are there for you to use to train your machine learning, your AI systems, to identify damage, to do whatever you want to do. It's all there, it's all free for anybody. Don't even have to be, well, you have to sign up for DesignSafe, but you don't have to have a NHERI project. Anybody, the public, can sign up. So another thing you could think of is these ears don't often work together. Gear and Steer do some work together. We try to coordinate with NER, but if you have a clever idea of how you can assist the ICER network getting the community to work as one, that would be wonderful. Because my big fear is we have a 9.0 earthquake on the Cascadia subduction zone, followed by a design level tsunami. That will be something we haven't seen in our lifetimes. Nobody's alive still from 1906. That might be the only other event that could compare. And even that, I think, is going to be nothing compared with what Cascadia is going to see if they have a design level earthquake and tsunami. How do these extreme event reconnaissance and research networks respond? How well are they coordinated? I don't think we're ready for something like that, but we should be, because it could happen today or tomorrow. It's that uncertain. Anyway, and once the data is collected, we don't always have all the attributes for that data. So if you want to use it for your machine learning, you might not have all the information on the thousands, millions of photographs that have been taken in the field. Somebody needs to figure out, how do we do that? How do we add all the metadata in an efficient way, not using undergrad students as we've done in the past, and ask them to go into Google Earth and figure out where this was and what it looked like before the event, et cetera, et cetera. And then finally, I've got another idea that some of you might be excited about. How about creating your own year? And this came to me because I heard just recently that the Rapid Center up in Washington, University of Washington, has just received a $2 million grant from the National Institutes of Health, NIH, to purchase equipment for monitoring environmental effects of hazards, like an oil spill because of an earthquake or a tsunami, and a gas leak, and Maui, in fact, has enormous environmental issues because of everything that burned in that fire. people were kept out for a long time because of the hazardous materials in the dust and the ash. So environmental extreme event reconnaissance. I've even got your acronym, NVER. I don't know. I like it. But so if that's of interest to you, why not? Put together a team, propose it to, it wouldn't be to CMMI. You'll have to find the correct directorate in NSF. But yeah, FEAR is through a health directorate. I think some of these others are also through different directors. They're not all through CMMI. So go ahead and think about it if it's of interest. Now, each of these ears also has a one-page expanded explanation back in the appendix, but it's pretty clear what they do. But you can take a look at Appendix D. And then finally, on that issue, having collected all that data, how do we enable and foster ethical, collaborative, and transformative research and outcomes? So what I want to point out here is I'm not going to touch on the ethical here, we'll touch on it later, but the collaborative and transformative research and the outcomes of that research coming from historical hazard events is phenomenal. I'm going to go through this list. San Fernando earthquake, not only did it cause major damage to Olive View Hospital, which any of you who've taken a class on seismic engineering will have seen a photograph of Olive View Hospital, because it was the turning point for seismic design in the US. There was some seismic design prior to that, but ATC3, Applied Technology Council, was tasked with developing seismic guidelines for our use. And they did that by 1978, which started the very first version of what we now have as the seismic code in IBC. That was a major turning point for seismic engineering. Hurricane Andrew did the same for wind engineering. It convinced us that a continuous load path was essential. It also convinced us that opening protection is necessary. So ever since, Florida has been one of the best, has the toughest code for wind engineering or wind design of buildings, and particularly residential buildings. The Northridge earthquake taught us that steel moment frames that aren't welded correctly can suffer major cracks. Fortunately, none of them fell down. But this led to a massive research project over 10 years to develop solutions to those connections. Now that issue is solved. This was the Structural Engineers Association of California, ATC again, and NHERI, the Consortium of Universities for Research in Earthquake Engineering. The SAC project produced what now are seismically acceptable moment frame connections that we can use, and that all is in the code. Hurricane Katrina, I mentioned before. Storm surge, evacuation, there was a lot that was learned and a lot of things changed in the code because of that event. Chile, a flood barrier design, the barriers around New Orleans, obviously not adequate. They were high enough, some water might have gone over the top, but you'll never fill up those neighborhoods with just water going over the top of the barrier. The problem was the barriers failed because that water going over the top scoured the foundations. The foundations were not anticipating overtopping. And once the barrier fails, then the entire neighborhood, the entire below sea level area will fill with water. And that was the biggest problem in New Orleans. The Chile earthquake, we realized, actually Jack Melly particularly realized that though the Chilean designers use shear walls a lot, so most of their high-rise buildings, concrete buildings, they're all concrete. Most of them have a significant number of shear walls throughout the building. Unfortunately, they were making them thinner and thinner, and often cutting them, curtailing them down at the bottom. It was not good design policy. So we've changed, others, not we, others have changed ACR 318 because of testing that was done in the US on shear walls to establish a minimum thickness and a slenderness ratio, which were not there before. The Indian Ocean tsunami in 2004 woke up the entire world to the threat of tsunamis, and the East Japan earthquake and the Tohoku tsunami that followed in 2011 were major contributors to the development of Chapter 6, Tsunami Loads and Effects, which first published in ASC 716, and continues in ASC 722. That would not have happened had we not surveyed those events. The Joplin tornadoes and other tornadoes, but Joplin particularly, led to the initiation by NIST of research to develop a chapter for tornado design. So as of now, ASC 722, chapter 32 has tornado loads. And the Marshall Fire and Maui Fire are going to significantly increase the adoption of the WUI codes, Wildland Urban Interface codes, which have not been adopted very widely and not always put into practice. I think that's going to change with these devastating fires that we've had recently. So sorry, spending a little more time than I meant to on data collection, but I think for a junior engineer, that is a perfect place for you to start. Collecting data for the ears virtually. Apply from that, you'll get ideas about what needs to be researched. Apply for a rapid, and you're on your way. You can work from that rapid to a hypothesis-driven major research proposal to solve a problem. And we do have 5 successful campaigns like that listed in this document that I'll show you a little bit later. I do need to keep track of my time. Okay. So research question number 2, what are effective and potentially transformative? Well, no, let me ask, because I said I was going to ask you questions. How many of you, maybe by raise of hands, how can I see my participants? Yes, I can. If you raise your hand, if you are a member of one of those extreme event reconnaissance networks, can you do that for me? I have Lauren. I have lots of hands going, oh, I love this. Oh, excellent. Yeah, I'm seeing quite a few hands. Well, I was looking at the top screen. I don't know if you see my attendee list that I'm showing on the, I don't think you do. But yeah, okay, the first screen had quite a few folk, but lower down, I don't see many hands going up. So think about it. I strongly encourage you to join one of those ears and get involved. Okay, let me minimize that. Yep. So moving on, what are effective and potentially transformative mitigation actions to achieve community resilience? So building code adoption just jumps to mind. If we could get every community in the US to adopt the current codes, we would be golden. Seriously, we would be golden. There wouldn't be the kind of damage and the tragedies that we're having now. And I'm sorry, but engineers are not going to get that done. I've testified often enough in front of our legislature and our city council to know that, yes, they listen, but somehow it's not enough. They make decisions that are not in the best interest of the public. So we need social scientists to help us figure out how do we get the community motivated? How do we get people motivated to push their politicians? It's not enough for 1 or 2 engineers to go to a hearing. We need the entire community saying, we're fed up with all this damage. We know how to do better. Let's do better. How do we improve community evacuation? It really is frustrating when hurricanes, we have 4 to 5 days of warning and very accurate paths in 2 days before the event. And still people refuse to evacuate. It just is, again, it's a social science issue, not really engineering. I wouldn't be able to solve that issue. How do we come up with the economical, efficient, implementable, easy to apply retrofit? The problem with retrofit is you're working with a building that is finished. And now you have to start ripping it apart to try to get the load path in or to try to strengthen a portal frame. It's not trivial. If you have ideas of how you can simplify that process and get it more effective, more implemented, that would be a major improvement. Safe rooms. We do have safe rooms, but they're designed for the very worst tornadoes. Is that all we can offer to the homeowner? Maybe there's something where we can offer a safe room that will see you through an EF3 tornado, but maybe not an EF5. That's better than not having one at all. And here in Hawaii, we've developed a Category 3 hurricane safe room, not Category 5. It's not the same as an ICC 600 or whatever the number is for the FEMA safe rooms, but it'll save people in Hawaii if they shelter in place. And by the way, if you're on an island, you don't have anywhere you can run. There is no evacuation except to a safe building. So sheltering in place is the primary option. And then how do we enhance utility resilience? The more of these utilities we maintain, the easier it is for the community to recover after an event. Power particularly, but water, we saw that in Hurricane Ian. I think 7 or 8 hospitals had to be evacuated because they lost fresh water. Water supply went out. And wastewater treatment is not a good thing if you're living on an island and you end up dumping all of that sewage into Waikiki. So not good for tourism. All right, next. So Babcock Ranch is covered in a single page in the science plan. You might have noticed it. It's a community somewhat inland from Myers Beach. They decided not to build on the beach. They wanted to get away from the storm surge, which they did. They've designed to current code, but they've designed their utility system to be almost not bulletproof, but to function during these events. They had power continuous through the event, all provided by solar panels. Their stormwater drain system goes underground. Their power utilities are all underground. Nothing's up in the air on poles. So it doesn't get blown down. It doesn't get damaged. Nobody lost electricity. Nobody lost water. The wastewater treatment plant functioned throughout. They didn't see the full design level wind speed at their location, but they did have the same rain that flooded other areas, and they survived. So my question is, how do we do that for everybody? I'm not sure what the price of homes there is. They may be paying a premium to get that benefit, but how do we make that economical so that every community can respond or can perform like Babcock Ranch? It has to be possible. So if you have clever ideas, that's a good one to work on. And the second part of that statement is, especially when considering changes in hazard exposure and community characteristics, emerging technologies and sustainable goals. So again, we come to social science implications of migration. A lot of people left southern Louisiana, Mississippi, after Hurricane Katrina, moved to other communities. So the communities they left behind change significantly. The communities they're going to change. They change. They've moved out, not out of their own choice. There are a lot of social science implications with that upheaval. What are the effects of climate change on communities and their built environment? A hot topic, obviously. The SimCenter tools cover modeling of community exposure, not only the infrastructure, the buildings, but also the human, the occupants. So those tools are extremely well advanced. If you enjoy simulations, that's a good place to start looking. Investigate nature-based solutions, bio-inspired design. There's bio-inspired liquefaction prevention. So using bugs to calcify the soil so that it doesn't liquefy as easily. There are a lot of other solutions, mangrove swamps to reduce wave action at the beach, or surge velocities, things like that. Utilizing new materials and construction methods. We should not be designing houses or buildings with an anticipated lifespan of 50 years. That is the definition of unsustainable, because we end up throwing away most of that material at the end of the 50 years if the house has not performed well, hasn't been maintained well. We should be designing for a 100-year minimum on everything we build. They're doing that now with bridges, dams, big structural port facilities. They're thinking of those 100 and 150 years, in fact. We should be doing that for residential buildings, because that automatically cuts the amount of energy and materials in half. The construction materials and labor and everything is cut in half if you can get a building to last twice as long as it was previously. And even when we do deconstruct, we need to be able to reuse, recycle, and use all of that material again. And think about that when we're building it in the first place, so that it's easier to deconstruct and reuse. All right, third research question. What are the key physical, social, economic, and policy drivers that influence the capacity for resistance, resilience, etc.? So the description. So each of these, by the way, has 1 or 2 pages of description. The primary intent is to identify vulnerability indicators and metrics, both social and physical, to be employed in resilience analyses. So not just looking at the physical, we need to include the community, the people, and the social interactions. Investigate the interrelationship of the infrastructure and the social systems. How does the one affect the other? And then under each of these topics, physical, think of retrofit, mitigation solutions. Their engineers can help. Think of the social aspects. Clearly, we need sociologists, psychologists for community education, preparedness, making them aware of their hazards, encouraging them to plan for evacuation and actually to do it when the time comes. Economic, developing incentives to act. The retrofit issues that they're considering in San Francisco are not going to happen if there's not an incentive plan. There has to be some state or federal money contributed to encourage owners to do those retrofits. Otherwise, it ain't going to happen. So economists, sociologists, again, working with building owners. Policy drivers, be an advocate. I mentioned I've been to a number of hearings and city council and state legislature hearings. When I see a bill coming up that is it's just counterintuitive, wanting to cancel new codes. Our governor has actually put a hold on our state building code council and told them, you're not to adopt any new codes from now until I tell you, because he has an emergency proclamation in place, partly for Maui, but partly for they hope to make houses more economical by not adopting new codes. It's so regressive, it's incredible. So we can go in, we can argue about those things. The first time you do it, by the way, you'll be very nervous. Don't be. These folk are just people. The politicians, they're just other citizens. They think they're something more special sometimes, but they're not. Just go in and do that. Advocate. If you hear of something happening to the codes in your area or to the city planning, they're deciding to put a new community in the floodplain, or they're deciding to do something stupid, go and advocate. Become a community activist. The term for it now, I guess, is influencer. Try to get people to follow you and agree with you and all go, write letters, submit testimony. It makes a difference. It absolutely does. If the politicians don't hear from their constituents, they assume they're making the right decision. We have to let them know. All right. Question 3, what are the, the last part is, those drivers, what are they that influence the capacity for resistance, restoration, and renewal, both of infrastructure systems and the services they provide? So I've broken down the resistance. This is, again, engineering, material, and there are advanced materials we can look at, developing new materials, improving design, optimizing our designs to reduce the amount of material we use, optimizing strength and stiffness. They don't seem to go together, but we need both to get things to work. Soil improvement techniques I mentioned earlier. Restoration, accelerated recovery. How do we recover our networks, the electrical, plumbing, water, wastewater, and renewal. This build back better, we have to get that to work. We have to, I'm currently working a little bit with FEMA, and it's still hard to get FEMA to increase the insurance payments. If you get flooded and you have national flood insurance, you don't get enough money to even rebuild the way you were, let alone to build back better. FEMA should be in the business of insisting that you build back better. So they are at least moving to insisting that you build back to the current code, not to whatever your community code happens to be. So we're making some progress. And then community cohesion. How do we help the community stick together? The Lahaina's community has stuck together pretty well. They're advocating for themselves as to how they should be. There's a lot of help coming in, but they want to be in charge of how they recover so that they remain a cohesive community. I think that's easier on an island because they're not going to move off to the mainland necessarily, though some may have. But yeah, they want to stay in that community. That kind of cohesion is, again, a social science issue. Moving now to more of sim center type tasks. In key research question 4 asks, what methodological innovations are needed to support community resilience through integrated modeling, analysis, experimental testing of constructed and social systems. So again, not just constructed infrastructure, but also the social systems under natural hazard stress. So changing this to a human-centered approach to our research. Before we start developing the new widget to prevent damage during hurricanes, let's think about how communities, how people are going to accept it. Are they even going to want it? Is it something that can be implemented? We have to make our engineering research human-centered because those are the people who are using it eventually. Making next generation human decision models, getting this, again, social science aspects, getting into the minds of how people respond, how communities respond, herd mentality, if you like. How do we develop models that make those, that inform us about how those decisions are made? Capturing data on complex interactions between the physical and the social vulnerability, how one affects the other. And often it's that the most vulnerable socially also are the most vulnerable because of their occupying older structures, not being able to afford the latest and the greatest. Developing multi-scale modeling and simulation capabilities. And SimCenter has done a lot of this, but there may be ideas you have that they haven't covered, they haven't tackled. Get involved. Speak to the folk at DesignSafe, see if they're already working on it. If they're not, they can maybe help you to develop your plan and get a proposal funded. Address the multi-hazard performance of utilities. It's just frustrating that we're still putting power lines on poles, just timber poles. It's depressing. We should not be doing that anymore. Underground. How do you do that more cheaply? The reason we don't do it is it's expensive to underground utilities, but we have to figure a way to do it more cheaply. Question 5. What barriers and opportunities are shaping the development of analytic and simulation-based techniques? So barriers and opportunities to the simulation tools. Developing improved end-to-end simulation. So not just picking on one piece at a time. And again, SimCenter is doing this. They're looking at all the way from a distant hazard to the effect it has on individual people and individual buildings, not just looking at individual buildings alone, but looking at the entire community as a composite of a lot of individuals and a lot of buildings. Connecting models and simulation capabilities across scales. Having a hurricane generated in the Eastern Atlantic and moving across, so you have the large meteorological model running the hurricane and carrying that through all the scales down to what's the pressure on a window on a building in this location or in this community. So trying to work across all scales to get realistic loading and effects on our buildings. Improving multi-physics simulation, fluid structure for storm surge, tsunamis, and wind, and building response. Soil structure interaction has been a keen area of research for geotechs for some time. And then combined wind and wave, the niche center will try to focus on research there, but there's a lot can be done with simulation already. And then one that I've always been interested is, though I don't have the skill to do it, erosion and scour. This is a three medium, if you like. There's air, there's water, and there's soil. And it's tricky to model. And it's tricky to get the results that you can rely on, because with a simulation model, you can create any answer you want, depending on what you put in at the front end. So the most important thing with any of this simulation is that you somehow validate the performance. It's a little more difficult with social science type aspects. With our engineering, we can validate them in large-scale experimentation or field observations. A lot you can learn. Field observations are full scale. It's like the lab on steroids. You get a major surge coming through real buildings, and you very quickly learn what happens. Same with scour and erosion. And you can start using those observations to calibrate your model and see if it's coming out right. Finally, key research question 6. What methodological and empirical gaps must be closed to characterize more accurately the transient and variable nature of the loading actions? So this is looking not only at the fact that these actions are maybe short term, but they're also extremely unreliable and unpredictable, so variable, but also including effects of climate change, which was not considered in the previous science plans. So quantification of uncertainty of loading actions from natural hazards, particularly in a changing climate. What do we expect? We're building buildings, say, for 100 years now. I'm telling you to design buildings for 100 years. Do we know what the climate's going to be like in 100 years? So look, if you want to know something about uncertainty, there's a lot of it there. So that's crucial, because we do want these buildings to last at least 50 years and hopefully 75 or 100. And trying to include the uncertainty in climate change effects is going to be very tricky. But somebody needs to do it. If that's your field, keep working at it. We need that guidance. And in fact, ASCE 7, the minimum design loads and other criteria for buildings, ASCE 7 has formed a new subcommittee looking specifically at the effects of climate change on our buildings in the future. It probably won't be a mandatory, it'll be an appendix or a non-mandatory chapter, but nevertheless, they're finally starting to look at it for the ASCE 728 edition. But you could get in there and help with determining some of the uncertainty or trying to narrow the uncertainty. Connect frequency and intensity of geophysical and atmospheric hazards data to site-specific loading actions. So as I was saying, the multiple storms going over Maria and, over Puerto Rico and US Virgin Islands, trying to take from the modeling of the hurricane all the way down to the effects on a site-specific building is not something we do. But if you can generate a model that does that reliably, that could be a very useful tool. All right. So any questions or any ideas or, yeah, I see a couple of chats. Let me get those quickly. So, okay, that was about the time of starting. All right. Joy Pauski. Oh, Joy, thanks for joining us. The ECI program supports gear and steer, and following a major event, typically gear and steer conduct preliminary reconnaissance, and based on their outcomes, ECI will support, if warranted, rapid awards. Steer typically has open calls after a major event for interested researchers to be considered for their virtual and/or field teams. The ECI program individual rapid proposals must demonstrate that the PI is well qualified, has situational awareness of the area to be investigated, has access to the area, has a specific plan for the field work. Can't just say, I'm going to go and look for damage. And by the way, don't just look for damage. Also look for buildings that survive. We can learn a lot from the ones that survive. What did they do right? So location, housing, equipment, you have to have your logistics all sorted out. How are you going to collect the data? What tools are you going to use from Rapid Center or your own? Make sure it's not duplicating steer and gear data that's already been collected. You need to be familiar with it's already in Design Safe. Has sufficient training. You need to have sufficient training in entering and working ethically in communities under distress. And this is a good point, Joy. Converge has developed, I think it's now 7 or 8 web modules, and a number of them are targeted at specifically this, how we as engineers or social scientists enter a hazard area and interact with the people who are there. It does take an ethical approach to doing that. You can't just barge in and say, oh, I'm here to collect data. I'm from NSF. That ain't going to sell anything. Yeah, make sure that it's ethically in communities under distress, that you are collecting data to answer specific research questions, and has a data archiving plan in Design Safe data depot. So start a project in data depot and have a way that you're going to store the data. Rapid proposals can only be submitted upon approval by a program director, with the email approval included in the proposal. So I was going to say this a little later, but as you're developing a proposal, don't spend months developing the final proposal without speaking to the director of the program. You might be wasting your time. And Joy, I'm picking on you, but I remember a time you came out to Hawaii and I pitched an idea to you. I forget what workshop it was you came to, but I asked for time to speak, and it only took you a couple of minutes to tell me, no, that's not a good idea. And that was extremely helpful. You saved me months of time trying to write up a proposal for something that didn't actually make sense. And I was a junior engineer like you guys. This was a long time ago. But we think our ideas are good. They aren't always. Approach the program director. So yeah, thanks very much, Joy. And a little bit more. Effective May 20th, 2024, NSF had his new proposal and award policies. And yeah, so what do we call that? PAPPG, the PAPG. NSF 24-1. So make sure you're following those instructions on how to put together your proposal. There's a link to see the changes. Now it's required. Now required is a graduate student mentoring program plan. Ooh, excellent idea. We just held a workshop at the University of Hawaii in our department to encourage faculty to mentor the junior faculty that we're hiring. We haven't had a formal policy in the past. It's terrible. But yes, this is an excellent move to require that if you're using graduate students, you have a mentoring plan. So NSF 24-1 requirements need to be incorporated into career proposals, along with the requirement in the career solicitation. Excellent. Converged training modules. Thank you, Joy. I should have had that link in my PowerPoint, but Joy has it for you in the chat. And you can search for it as well. It'll pop up. And Marty LaChance is saying that STEER has activated phase 1 reconnaissance for the recent Taiwan earthquake. Yeah, we did the PVRR. We're still working on publishing it, but there's enough information to learn there that we are going to have a team constituted primarily folk in Taiwan. There are a lot of good earthquake engineers. We don't need to be sending a lot of people from the US. So thanks for those chats. I will try to keep track of when new ones come in. So please, Joy, others, put things into the chat. Any questions from others on the workshop about the research? Did you find, yeah, let me do another poll. Hands up. Let me just get you open first, sorry. Hands up, everybody who could see in what I just went through, in those 6 research questions and all the items I covered, did you see something that would apply to what you're thinking of doing as your research focus? Raise your hand if you saw something that applies to you. All right. Now, if you open up the attendee, I don't know if you can see the attendee list though. Oh, I didn't assume that. Can somebody tell me, are you seeing the attendee list that's on my screen now? Because I'm sharing my screen, but I don't think this shows up.
We don't see it on your screen, but we can see it on our own screen. So we're seeing it.
Okay, good. This is not a webinar. I know in webinars, you can't see who's on the call, so you can't see the stuff. Good. But you'll see that a lot of people have raised their hands. That's what I'm hoping. I'm hoping something in this science plan resonates with you and could be useful for you to use in your future research proposals. See another chat. Let me get that. Oh, yes. Okay, you can see it. Good. Thanks very much. And if there are any questions, please just unmute yourself and speak. I'll stop. I really do want this to be as interactive as possible. So there is a section in the science plan that we retained from the second version of the science plan dealing with disruptive and transformative technologies. So there are a number of ideas here and some of these are now becoming mainstream. Advanced computing, NHERI, SimCenter, and Design Safe. You are set up with the best possible advanced computing facilities. The TAC Center is phenomenal, and if you're looking for advanced computing capabilities, write a proposal. One of the beauties of computing, of course, is because the advanced computing will be free through Design Safe. Your simulation proposal doesn't have to have a huge budget. So try to get in. If you get a NHERI proposal, you can use those facilities immediately. Social sensing and modeling, something that needs to be And again, as an engineer, I'm not sure how one does this. But social scientists can look at how they monitor social attitudes, how they model that as part of a hazard modeling or a vulnerability modeling. AI and machine learning now become mainstream. It seems like everybody's using them. I did see a presentation the other day where, you know how machine learning works. You get a huge amount of data. You use about 80 or 90% of it to train your model, and then you save the other 10% to test your model. And they thought, wait a minute, if I'm testing the model on the same kind of data that I trained it for, it'd probably do fine. So they found another bucket of data that was on the same topic, but wasn't part of the package they'd used for the training. And some of the machine learning models that are out there, some of the tools that are out there, didn't do a very good job at all with that second package of data. So do be careful. Don't assume that because you've trained it on 90% of your data and it matches the other 10% when you do the test, don't assume that you have the right answer. Try to find another set of data that you have not used for the training, just completely separate from yours, but on the same topic, and run it through your AI and see if it works. So just a caution. It's a black box, right? Big black box, one that I don't even understand, but it is an amazing tool if you get it to work right. Bio-inspired engineering solutions, those I've mentioned. Additive manufacturing is 3D printing, but it's really gaining ground. I'm thinking housing-wise in hurricane zones, building concrete houses by additive manufacturing is becoming a fairly common practice around the world. I haven't seen a lot of it in the US yet, but it'll happen. That may be a way to manufacture homes very rapidly and somewhat economically that are resilient to strong winds and at least will survive the storm surge. You have to clean them out afterwards, but rather get out of the storm zone, the surge zone. What? I repeated AI. Sorry, I didn't mean to repeat them. So those aren't the only ones. This is just a list that we have in the science plan. Any new ideas, emerging trends, by all means, leverage them in your research. Another thing I'd love for you to leverage is the TTC. The NCO developed this new committee, Technology Transfer Committee. In about 2017, we initiated that group. This is a group of 15 to 20 practicing engineers, knowledgeable about how you get engineering solutions, new ideas into practice, either through publications, as geotechs do, and get it into practice, or through the codes, as applies to a lot of structural and other applications. We don't expect you as an assistant professor to know how to get the research results into codes. In fact, you might not even have thought that that's necessary or that's your next step. You're looking at publishing papers because you get to get tenure, and papers are what get you tenure. But believe me, the satisfaction from getting something you've worked on into the building codes is enormous. I talked about the tsunami chapter. I am extremely proud of having been involved in developing that chapter because I think it really is going to help in tsunami areas in the future, tsunami prone areas. Quick point from Joy again. If you are interested in reviewing for the ECI program, please send her an email, jpauschke@nsf.gov, expressing your interest and include a 2-page bio sketch. Excellent. Thanks, Joy. You can probably expect about 36 bio sketches. Yeah, these 15 to 20 volunteers have expertise in all of the areas that we're dealing with. So everything is covered. Whatever you're doing, there'll be somebody on that committee who can assist. They've developed this white paper. You can scan the QR code, or you can just search for TTC on DesignSafe. They have a web page, and you'll see a link to the paper there. It describes common mechanisms for how we get research into practice. But you can contact I should have given you the director, oh, help me, Marty, I'm forgetting, and he's Bill Holmes. Bill Holmes is the chair of this committee. And if you contact, I should have put his email address in here, but if you search for Bill Holmes, and he works for Rutherford Shaquem, I think, he'll pop up. But yeah, send him an email and he will put you in touch with one of these volunteers who can help you, guide you through your project. My suggestion is that you get them involved in your proposal writing stage. Get them involved right at the beginning, not when you're running experiments already, because maybe your experiments don't cover all the parameters that need to be covered for it to go into practice. And they can help you with that. That's what they're there for. And quoting Susan Margulies, the Assistant Director of NSF Engineering Directorate, NSF long has sought to accelerate the development of technology from fundamental research to move innovations into practice, create those partnerships that make it all happen. For a long time, we thought NSF is really just science and cutting edge, new inventions, new discoveries. But really, they are turning to this idea of getting innovations into practice. So they have a new TIP, T-I-P, technology, I want to say technology, innovation, practice, but I'm probably getting it wrong. But if you search for TIP, NSF, you'll find the ways that NSF is trying to help fund that gap, that transition between the end of your research project and actually getting the stuff implemented. We got a number of chats now, good. Somebody is Joy. Yeah, Bill Holmes. Thank you very much, Marty. And Joy Powski saying, if you are not sure if your proposal topic fits the ECI program, send her a one-page abstract along with that bio sketch you're going to send her. A one-page abstract describing the proposed research, intellectual merit, and broader impacts. And there's a NSF funding opportunities. The rapids don't have a deadline. You can submit a rapid request anytime. And I think it's the same now with full proposals. There are some that are solicited with a deadline, but many of them, you can submit them at any time. And Joy and her teams, she sets up review teams, will review them biannually, twice a year, I believe. Bill Holmes, there's his Rutherford Shaquem website. So my memory is not getting that bad yet, but it'll happen. All right. All right, so TTC, I will actually mention the TTC a little bit later as well. So we include in the design, in the science plan, 5 successful research projects that went into building code implementation. So Elena Sutley realized that we don't have, we elevate homes for surge, for coastal design, but we don't have wind pressure calculations for the soffit of that slab, of that floor. We've never looked at that before. And so she ran a program in the, I believe it was at FIU. Might be wrong, it might have been, yeah, it was FIU. She ran a research project, wrote a proposal based on her inspection. She went out to Hurricane Michael and she looked at these buildings. This is one of her photographs during the field inspection. And she realized this was a deficiency in the wind codes. And so she wrote a proposal, got funding, ran experiments, validated what she saw in the field, compared it between full scale and model scale to verify that the model scale works equivalent to the field. And that is now in the code, ASC 722. It took her less than 5 years to go from survey, Michael, to getting into the code. So it can be done. It helps if you are a member of one of the ASCE 7 subcommittees in your field, well, wind, geotech, seismic, whatever your fancy is. The next one is Forest Masters, machine learning and atmospheric simulation to study topographic effects on extreme wind speeds. So after the 2017 hurricanes that hit Virgin Islands and Puerto Rico, he wrote a proposal, got money from NSF and from FEMA and I think from NOAA to work on modeling in the wind tunnel, in a boundary layer wind tunnel, the topography of at least portions of Puerto Rico to get the topographic effects on the wind speed. I mentioned at the beginning, and I do it every time I present, that I am the Arthur Chiu Distinguished Professor of Structural Engineering at the University of Hawaii. Arthur Chiu experienced this topographic effect in Hawaii after Hurricane Eva. That was 1982. And then it happened again in 1992 with Hurricane Iniki. And it was his life mission to get topographic maps for wind speed for Hawaii. Unfortunately, he passed away suddenly of a heart attack just before that a project was completed, doing exactly that. And so Hawaii was one of the first states to have a fully topographic map for the entire islands. And the wind speed changes by up to, the pressure. There's a coefficient for topography in the pressure equation, and it goes from 0.9 up to 1.6. So about a 70–80% increase in wind pressures just because of the topography. And the reason that's not in the wind code, or wasn't in the wind code, the ASC 7, is because most of our high wind events are in Florida, Gulf Coast, East Coast, which is flat. There might be small terrain effects, but there's nothing like Puerto Rico or Virgin Islands. So now maps are available on ASC 722. You can go in and you'll have wind speed maps for, you go into the hazard tool, and we have mid-speed maps for Puerto Rico, for Virgin Islands. Guam also, I believe, has been done, and Saipan. So eventually all of the territories will have these topographic, and I thank Arthur Chiu for initiating a lot of that work. Jamie Paget, chair of civil engineering in the University of, in Rice University, Houston, my alma mater, saw the issue. We saw this issue in Katrina. I just didn't have the wherewithal to say, well, we should study that. But Jamie did. Got a research project to study the effect on above ground storage tanks during storm events, both wind, debris, and particularly surge, because they float. And they are hazardous materials then spread everywhere. You might have seen videos of this phenomenal experiment. This is Shilling Pei from Colorado School of Mines. That's in there. This phenomenal timber 10-story building using cross-laminated timber or laminated timber. There's a better word for it now, and I'm losing it. But this has been used for an enormous amount of testing, not just the timber frame itself, but also for payload projects, for non-structural elements, new sensors, whatever ideas you have that you think you can put as a payload. I'll give you another story. I know I'm sort of getting off topic a lot here, but I'm hoping you're going to bear with me. Yeah, okay. John Van der Lent at yeah, he's at oh man, he's not at Boulder, right? Shoot, I forget. But anyway, John Van der Lent now runs the NIST Center for, I should know what it means, community resilience. But we were running tsunami experiments in the wave basin at Oregon State University in 2005, 6, 7. And we weren't using the entire basin. We had built flumes along the one edge of the basin so that we could use the tsunami generator in that basin. And so John Van der Lent put in a proposal to do a study on a scale model of a wood-framed 2-story house in the rest of the flume. A very small funding project, but that got him started in tsunami resilience of timber frame structures. And he continued to a number of larger projects after that. So yeah, think about payload projects. If you see something like this happening, contact the PI and say, you know, I have this new widget that I think can measure the deformation, relative deformation between floors. Or I have a new way of attaching gypboard where it won't get damaged during an earthquake. Get a payload project added to one of these. That's a very good way to get in to explore your idea and see if it's going to actually work in reality. And this is reality. This is a full-scale 10-story building shaking to real-life severe earthquakes. They start small, but they end up pretty severe, and you can test your systems. Here's the link in this chat to the TIP, the NSF TIP directorate that I mentioned. Thanks, Joy. ECI has no proposal deadline, right? You can submit a proposal at any time. And Colorado State, that's where he is, Fort Collins. I think it's Fort Collins. I don't know. But anyway, Colorado State is where John Van der Lent is. And then another one was 2 researchers, Edward and Arash, working on mitigating microbial-induced desaturation. So soils liquefy only if they are saturated. And so this is a new approach, MID, to reducing and maintaining a low level of saturation in soils that would otherwise liquefy. And with the help of the thumper from, not thumper, this is T-Rex, this is the big one, from University of Texas, and Skokie, I forgot Stokey, Ken Stokey, the PI, they were able to prove that that works. And that now is once they've published, geotechs can now use that as a remediation of liquefiable terrain. A very useful discovery. So those are success stories. Hopefully when we write, Joy, you need to close your ears. Hopefully when we write the 4th version, no, I'm not working on the 4th version of the science plan, but anyway, if there's a 4th version of the science plan, maybe one of your projects will be one that we're featuring as a success story. These are not, Shilin Pei is a seasoned researcher, so is Forrest Masters to an extent, but the others are junior researchers. You can get in come on. You can get into that level of proposal. Colorado School of Mines, that's it. Shilin Pei, Colorado School of Mines. Thanks, Joy. All right. I mentioned the research campaigns that were developed by the task group at our workshop in 2022. There are 7 of them. Again, I'm not going to go through these in detail, but I want you to look at them because I think you will find something that will mesh with what you're interested in doing. This one's understanding and reducing vulnerability of low-income communities to windstorms. We see mobile homes and poorly designed, poorly constructed residences being destroyed, and unfortunately people dying and being injured as a consequence. That's unacceptable. Society should not allow that to continue to happen. And we have a part to play. It's, again, not just an engineering solution. We know the solution. You just got to tie them down better and build them better in the first place. That's too trivial. It's to get the communities to do that and somehow support folk who don't have the wherewithal to do it themselves. How do we support those people? It is in our societal interest to do that. So yeah, how do we do that? I think that's a major social science challenge to solve this problem. Next one is the threat I talked about of the Cascadia subduction zone causing a mega earthquake followed by a mega tsunami. So how do we deal with this event? How do we educate the community that this is a potential? Again, social science needs. How do we advance the simulation of this complex combination of hazards? How do we deal with earthquake loads, earthquake shaking, sorry, earthquake doesn't apply loads, it just shakes the ground. But the resulting loads in the building, how do we minimize damage so that when the tsunami comes, the building can still stand up to the tsunami? How do we deal with that very rapid sequence of loading events, quite distinct, quite different loading events? So there's some research going on that now, but there's a whole lot more that could be done. How do we advance the design and construction of VERTs, vertical evacuation refuge for tsunamis? How do we encourage people to use them? It might be hard to look at a building in the tsunami zone and say, well, am I supposed to go up that building? Who designed it? Well, the way these are designed, according to ASC 716 and now ASC 722, they are the toughest buildings, maybe apart from a nuclear power plant. They are the toughest buildings that will ever be built. They have less than a 1% chance of failure, even in a full design, which is a 2,500-year return period, earthquake and tsunami. So they are virtually bulletproof. The chances of failure is very small. So how do we get people to believe that? I can say it, but how do we convince folk that that is the right place to go? And how do we coordinate all of these ears? If you're interested in working with a variety of ears, this might be something you can help with. Sign up with ICER, who take that function. And how do we, I think there is a workshop coming up soon, looking at this issue of how do we all collaborate. But yeah, I think we're going to be cats running around with our tails on fire when this thing goes off, because we're not ready for it. And we should get ready, because as I said earlier, it could happen anytime. Cascading and compounding impacts of natural hazards, an earthquake causing landslides or liquefaction or dam failures, fires triggering chemical spills, gets back to that environmental monitoring issue. So Joy, you heard my idea about NHERI, right? Environmental Extreme Event Reconnaissance. I'm assuming it wouldn't be your directorate, but you might be asked to review proposals if they come in. We'll see. I'm not going to write a proposal on it. I'm not a junior engineer anymore. I'm close to retirement. In fact, I'm 5 months from retirement. Anyway, moving on. There's a question from Lauren. I've got to run to another meeting. Sorry. Yeah, okay. I'm sorry this was delayed. It's because I was traveling and the flights didn't work out to get me here in time to get started at 1 o'clock, which I think is when we were going to start. I think that's somebody else who has to jump as well. All right. Next one. Sorry. Come on, slide mate. There we go. The next one is community-driven integrated research campaign for hurricanes. So this is an attempt to start with the community. And that's something I can't stress enough. If you are working with a test bed, or if you plan to do something like this that is going to help a particular community, you need them involved in the proposal writing stage. So I'll tell you my own embarrassing story, which was I was working on a university, what do we call it? Engineering Research Center, right? One of these big, if you get it, you're made for life. $5 million a year for 5 years, essentially, and the potential to continue. So Engineering Research Center, and my dean came to me and said, we've got to try for this. So we put together what I thought was an excellent proposal, and it got some very good reviews. But in the proposal writing process, we were contacting the communities that we wanted to work with, and one of them was in Alaska. And I contacted the University of Fairbanks and Anchorage, and they said, you're already writing the proposal, and you haven't spoken to the tribes yet. That's not good. You need to have them involved from the very concept, from the very initiation of your idea. You need to have the local communities involved. Otherwise, you're going to come to them with this fancy idea of how you can solve their problems, and they're not going to be interested. So if you're working with communities, start with the community. Find the folk who are advocates for that community, the leaders, the spokespeople, and get them involved in your proposal, in your project right from the beginning, and have them work with you throughout. You have a much better chance of getting your results implemented if you do that. Let me try more chats. Several people have raised hands. Yeah, I think I'm unfortunately losing a few people because of the change in time. Yeah, I'm sorry about that. But I hope that those who have to leave early have gained something from what you've seen thus far. There's another one on the effects of climate change, particularly induced migration. I talked about this with Katrina and with other disasters, people moving away from the community that they've known, they've grown up there, their grandparents lived in that house, and now it's gone. This is a traumatic experience and very difficult for people to recover. Kids get affected by moving schools multiple times, trying to find a new home. Laurie Peake has done some excellent work subsequent to Katrina on the effects that it has on the people who have to migrate. It also has effects on the communities to which they move. Suddenly an influx of refugees from these disasters makes it difficult for the folk who are welcoming them to their community. So a lot of social science aspects again. Thanks, Joy. Another comment from Joy. NSF 24.1 now requires approval from, there you go. Maybe I should have read that. Well, it wasn't out when I was doing this. Requires approval from tribal nations in the proposal if you're requiring or using their resources, or else the project will not be supported. I would go further to say, if you haven't even spoken, even if you aren't requiring or using their resources, if you haven't spoken to them, I think Joy should turn you down. you really do need to get, and it's not just the tribal nations, it's also the communities, regular communities along the coastline if you're doing that work, or earthquake, or wherever you're working. Talk to the communities, find out their fears, their understanding of their hazards, and how you can fit them into your proposal. It's extremely important. Thanks, Joy. And then another issue, we had one group that was going to work on these effects of climate change, and they came up with 3 different research campaigns. That was the first one, the migration. The second one was, how do we start building with net zero building materials and make our construction fully sustainable, so that the life cycle of the building and moving on to the next building requires the very least amount of emissions, the least amount of energy. So some very good suggestions there. This is a picture I noticed when surveying Japan after Tohoku. The Japanese were doing an amazing job with sorting out all of the materials. They weren't dumping it in a landfill. They were putting it in these huge piles and separating the timber from the steel, from the aluminum, from the glass. Everything was going to be recycled. Nothing just dumped in a landfill. And the last of the 7 is securing our nation through communication and education, or sense. Education, as we've seen throughout all of these, education of the public, education of engineers, social scientists in college, and K through 12. That's where we'll get the community on our side. And so this could be run as a single project, or campaign, or even better, integrate some of these ideas into your proposals as the broader impacts. So broader impacts can be putting the final products into practice, actually making a difference to the way we build in the future, but also in educating the workforce that's following us, coming up and doing this work in the future. Just check another chat from Rebecca. Community involvement. I've been worried about wasting people's time, getting them involved in the proposal process, because I think you were saying there isn't any funding to get the work done. Yeah, you're right. Shoots, now I'm moving to another one. Let me come back. Yeah, so you're right. In the funding process, in the proposal drafting process, there's no money, right? You're doing that out of your university. University supports you with a salary to write proposals. So you're not getting paid by anybody else to do that. And if you're including people from the community, they have to be doing it as a volunteer. But there you'll find people, an advocate for a community leader. They're the type of people who will volunteer for this. If you can sell them on your idea and they see the potential for your idea to help their community, they'll be on board. It's the same with the TTC. The TTC is unpaid. They're all volunteers, but they are willing to help you because they can see the benefit of what you're doing when it eventually gets into practice. So no, don't be scared that yes, you are asking for a favor. And if they don't want to do it, there's nothing you can do except look for somebody else who might be interested. So don't feel that you're wasting their time, and make clear to them that there's no guarantee, particularly at NSF, there's no guarantee of funding, but you would like them to help so that you're not creating something that is not going to be implemented. But good question. Yes. All right. So the suggestions here were that we need to reframe hazards and disaster resilience through education. We need to redefine our conventional concepts of infrastructure, and we need to revamp our education system so that we create a more interdisciplinary approach to hazards. And, I teach structural steel, concrete, and then I teach structural loading, and I teach seismic, I teach wind, I teach tsunami, I teach storm surge. I do talk a little bit about getting them all together, but yeah, we need to do a better job of teaching. And that's just in engineering. We need to involve social science in our engineering courses and vice versa, so that we are truly interdisciplinary, not just including all hazards. I mentioned the second science plan having 5 research campaigns similar to those 7 we just looked at. We decided not to update these, leave them just the way they are, because they're very good the way they are. So don't think, if you can't see anything in the 7 I've shown you, go back to the second science plan just search for NHERI Science Plan 2nd edition, it'll pop up. Resilience of lifeline systems, mainly a seismic issue. Immediate, that's what they deal with in that campaign. Immediate occupancy of low-rise buildings following windstorms, trying to get the Babcock Ranch idea into all low-rise buildings. Mega disasters, this is a sort of precursor to the one about Cascadia. Community level management of storm surge and tsunami hazards, and comprehensive numerical simulation platform for hurricanes and tsunamis, from source to impact, from a hurricane generating off the west coast of Africa to the impact on individual communities and buildings somewhere on the Gulf Coast. So please look at those as well. So this may be the piece that I should have started with, but I wanted to make sure there's some time for it. The keys to success for a NHERI proposal, not only a NHERI, but any proposal, but we obviously are talking about ones that use NHERI facilities. Develop a credible research question. And that's the most important thing, is to come up with a good idea, send that to the program director, Joy, if it's in the hazards area, the NHERI area, but anybody else, any other director, send it to them as a one-page white paper, and get their feedback. Don't waste your time on an idea that you think is good, but might actually not fly. Include demographically and functionally diverse research team. The only proposals that really are single person proposals, single PI proposals anymore, are career proposals. It's rather unusual for other single PIs. It happens. I'm sure NSF is still funding single PIs, but the emphasis is on multidisciplinary or interdisciplinary diverse research teams. The whole convergence aspect of research is important. And so try to get that diversity and include other universities, include minority serving universities. Yeah, spread the web, or what do we call it? Spread your net and collect the best people that you can find to help develop your research proposal. Include social scientists. As I said, anything we do as engineers is eventually going to be, hopefully, used by people. And we don't understand. I'll speak for myself. I don't understand people. My wife does. She's a psychologist. We need those people involved to help us as we work through. Economists, is it even feasible? Is it even economical? Is anybody going to use your idea? Urban planners, policy analysts. How do we get the community leaders, the city council, the county council, the legislature, to adopt policies that make this new idea formal and mandated? Yeah, very difficult, but there are people who can do that. Build a credible team. Similar to previous, convergence is one of NSF's 10 big ideas. So interdisciplinary research, we've worked in our silos long enough. We need to break down those silo walls and work with people with whom we may not have a common language even. We may have to develop a common terminology, how we discuss issues, but we have to do that. Contact the NHERI facility. If you're planning to use the wave basin, find out what their availability is, what their sensors, what they have to measure. Are they going to be able to measure what you need, or are you going to have to buy some sensors as part of your project? And discuss your research plans with the facility staff. These are smart people, and they've been running those facilities now for at least 5 years, many of them for 15 years, because they were part of NICE previously. They know what they're doing, and they will have some excellent ideas for you to improve your research campaign or your research project. So don't even submit your proposal if you haven't spoken to them, and speak to them early. It'll guide what you write in your proposal. Get letters of collaboration, but only from folk who are supporting. So, for example, the tribal nations that you've spoken to, you would need to get a letter from them confirming that they are on board, that they're willing to participate. But don't send letters just from your advisor or your dean that says, oh, we think this is a wonderful idea, please fund it. That's not helpful. That's not what we mean by collaboration. Collaboration is where somebody is supporting, volunteering, donating, providing something in support of your project, materials, equipment, time, funds, etc. If your research project involves a test bed, and I just talked about this, with an existing community, get them involved early. Don't wait until the proposal is, even if you get the proposal funded, you'll be happy, but then you approach the community and they say, well, we're not really interested. And then where are you? You've promised NSF you're going to work with this community, and now they're not interested. So talk to them early. Where appropriate, include a team member experienced in industry implementation. The TTC is there to help you. And again, I have to tell the story, but for the tsunami design, we got a proposal funded by NSF in 2005. It wasn't funded in 2004, even though we got very good reviews. February of 2004, it got turned down. And then the Tohoku, the Indian Ocean tsunami happened in December, Christmas Day of 2004. We were working on renewing the proposal and resubmitting, which you should do, by the way. I think I have that here somewhere. Don't give up. If a proposal is rejected the first time, unless you're getting poor response across the review, then you can throw it away. If you get reasonable response with good suggestions, follow those suggestions, modify it, resubmit. We were doing that. And then the Indian Ocean tsunami hit December 2004. So we put the proposal back in, much better proposal, in 2005, and we got the funding under the NIS program. One of the people on my committee, on the team, was Gary Chock, an engineer I'd worked with here in Hawaii for many years. And have worked with since. He was on the ASCE main committee, ASC 7 main committee, and on the wind committee. He was the lead of the tsunami committee. After this project, and then surveying damage at Tohoku, he and I decided it's time to write a chapter for ASC 716. And we put together a team of 30 people. I guarantee if Gary Chock had not been on my project from 2005 to 2010, there would not be a tsunami chapter in ASC 7. That's bottom line. But having a practitioner can get that stuff moving. Having somebody who knows ASC 7 is on the committees is how it gets done. And so, yeah, I'm very glad that I worked with Gary Chock on that. And I'm still working with him on all sorts of things. Plan from the outset how the research can be incorporated into academic curriculum and practice. We saw that in that sense research campaign. They've got some excellent ideas of how to do that. Include a timeline. Is your project going to produce results in not just papers, but actual implementable results in 2 to 4 years, or medium term or long term? Is it going to take 10 years or more? Are you working with fundamental ideas that are going to take time to generate? NSF would like to know that, I suspect. And then don't be shy to give your proposal to people you trust. Unfortunately, there are unscrupulous folk out there who will steal ideas and put them in as their own. It's just unfortunate, but it happens. But you need to have other people read it, people who haven't seen it, who haven't been in all the meetings talking about it. Get them to read it and give you feedback before you submit it. There isn't a deadline now, as George just said. We used to run up against the deadline, and we were just furiously trying to get the proposal finished to get it in by Friday, 5 p.m. local time. And there's just no time for a red team review, but you can do that now. Take an extra week, get a group to review it for you, and then modify it based on their feedback. One more chat, sorry. Thank you, and very informative. Sorry, he has to go to Dubai. That's Shafiq. Yes, okay, thanks, Shafiq. Shafiq is just, he's essentially going to replace me at the University of Hawaii. We hired him. He started this January. And I'm just thrilled to have him there. He's been working with STEER for 2 years now as a postdoc, and I'm stepping down August 1st. So I'm hoping that Shafiq can carry forward on hazard mitigation work in Hawaii. Well, I will too, but not at the university. All right, so that's the end of my. I was planning for this to go for an hour, and I've gone over. But the third edition of the science plan, I believe, will serve as a roadmap for NHERI researchers and others working on mitigating the effects of natural hazards on our community. And not only for the next year, because NHERI technically 2025, unless Joy has information for us, but no, she's not going to share it now. But I believe at the summit, if anybody is going to the NHERI summit coming up in May, we're going to hear from the group that we're looking at what would be the best approach for continuing this kind of work into the future. After what I saw, Susan Margulis, and I've got another quote of hers here, she was talking to the Science and Technology Committee of the Senate, the federal Senate. Now, there's a nervous place to testify. Damn, I'd need a new pair of shorts after that. Yeah. Anyway, Susan Margulis did a very good job of was looking at continuing funding the NHERI and NWIP, the wind and the earthquake programs. And she featured NHERI. That was the part of NSF that she was proud of. And in fact, featured Elena Sutley's project. Didn't mention Elena, but it featured that project as one of the ones that was a success. So I believe NHERI will be around. I can't speak for Joy. Here we go. There's the sign up. Joy has posted the sign up for the design for the Natural Hazard Summit. Yeah, if you can get to DC sometime, it's in May, I believe, but you'll find out on that website. Come to that summit. You'll meet most of the researchers involved in NHERI, and you'll meet Joy and others like her, other directors that come because it's right in DC. That's why it's being held there. May 14th to the 15th. I'll be there presenting on this science plan and running an in-person workshop where hopefully, yeah, I struggle with the online getting interaction with the audience, but I'm hoping that you've learned something from this. Susan Margulis' quote here is that NHERI and other scientific networks are critical to move quickly at speed and scale to go from basic research, fundamental engineering research, to implementation by individuals, communities, and other agencies. That is our mission. And I'm hoping at least you've learned that from this presentation. Any questions? Please just put them in the chat. Yeah, you're welcome, Wade. But yeah, any questions, please put them in for me. And I hope, Joy, that I haven't spoken out of turn on anything. I'm hoping that what the advice I've given is at least okay. Any questions? For me or for Joy, actually. If you want to type in a question, I'm sure Joy would be happy to answer. It's not often you get a direct line to the director.
Hi, Ian. Thank you
Yes.
for this. This was great presentation, and I think the suggestions you gave on the proposal topics and the suggestions on writing the proposal itself, I think can be very helpful to the attendees at the webinar. And I'm happy to answer any questions too. I'm gonna probably log off at 4:30, and I'm sure Ian's probably ready.
Yeah. I've been standing because I couldn't sit on my knees for too long. But yeah, it's an inconvenient doing this at the airport, but I hope people didn't notice too much. Any questions for Joy? Or just general questions on the science plan? Don't be shy. Joy's not a senator in the Senate or a politician. She's very friendly, very approachable.
But you can always send me an email with your questions. We're happy to answer them.
Yeah.
But if you're writing a career proposal, don't wait until July to start sending us questions. You need to be working on your career proposal already. So the sooner, if you have questions, the sooner you send them, the better.
Yeah, there is a deadline for the career proposals, right, Joy?
Right. It's the fourth. I can't remember if it's fourth Wednesday or Thursday. It's posted in the solicitation.
Yeah, but that's not like the others. It has an absolute deadline once a year, and do go for it. I didn't get one. I tried, but I was junior like yourselves, and it's hard to know. I figure if I was writing one now, I'd do a much better job. But that's not the point. We're trying to get NSF is trying to get young investigators like yourself, get you up and running. I think Elena Sutley was probably a career awardee. A number of those others that I featured might have been. It is an excellent start to your career, a solid amount of money for funding yourself and a student, at least one student, for the first 5 years of your career. I can't think of a better prize to win. So definitely apply, but do a good job of it. Actually, something I didn't mention, another thing you can do is volunteer for review panels. So NSF reviews all of these proposals, and they need people like ourselves to do that review. And I went on a couple of those as a junior engineer like yourselves, because it's an excellent way to learn what makes a good proposal and what makes a bad proposal. And I was surprised when we were reviewing 20 proposals, for example, I was surprised how many of them you could just throw in the trash can without even thinking about it. 5 to 10 of them were just people were throwing some idea out. They hadn't formalized it properly. They hadn't worked through it properly. They didn't have good broader impacts. I don't know if you still get proposals like that, Joy, but I just thought these people have wasted their time and my time trying to read this thing. It's just, yeah. So put a lot of effort into it. Make a commitment to take months to put together that career award, that career proposal, because nobody's going to give you $500,000 for a shoddy idea. It's not going to happen. All right. I'm not seeing any other questions. I really appreciate you taking the time to join, Joy. Very helpful to have you give that input on the chat.
Well, thank you again, Ian, for putting this together. I saw Billy, who was also instrumental in the Science Land. Billy Edge was on the webinar, and thank
Oh, great. I
Dave,
didn't see. Yeah.
Nancy, and Marty Latans for putting this webinar together. I think it was a great opportunity for early career researchers to hear about the science plan, and I think a lot of good proposal writing tips were also given in the webinar. So I think that would be very helpful too. So thank you very much, everybody who took the webinar.
You're welcome. And this was recorded. I'm not sure who was in charge of the recording, but I presume that can be posted on Design Safe, and Marty, maybe you can send out a blast so folk who weren't able to attend and who were put off by the time change would be able to view it. All right. Thanks, everyone. I'm going to sign off. Thanks, Natalie. I think if you were running the show, or Marty, I'm not sure who was in charge of this. I struggled to find the link to get it. Yeah, I must never do this again in the middle of traveling, trying to run a workshop. Not a good idea.
Ian, it turned out great.
Yeah, thanks.
What do you think? It was well worth the 2 hours.
Yeah, definitely worth the effort to put it together as well. Yeah, I think there are about 36 folk on the call at the most, so that's good. It's a good chunk of folk who can benefit, and I think others might be able to see the video. It's a lot to sit through me talking for an hour and a half, but anyway, c'est la vie. All right, I'm going to see you, Billy, at the Summer Institute, right?
Yes.